Hey guys, today we'll talk about fixed point binary representation. So let's say we have an integer number 13. Okay, we know how we can represent this number 13 in binary format. So this is 1101. Now we can easily verify how this is binary number represent 13. So what we usually do is we know the position of this one is 0, this is 1, this is 2, and this is 3, right? These are the position from LSB to MSB. So this is our LSB and this is our MSB. And what to get an integer number, we simply multiply with the scaling factor of with the 2 raised to power. So this is 1 into 2 raised to, so this is 1 into 2 raised to 3 plus 1 into 2 raised to 2. So this is 0 into 2 raised to 1, and this is 1 into 2 raised to 0. So if we sum them up, this is 8, this is 4, this is 0, and this is 1. So this is 13. So we have verified. Now, what if we want to represent a number, let's say 13.5? So we have two parts here. So we have an integer part. So this is an integer part, and then this is a fractional part. So integer number, we know how we can get it. So this is 1101. So similar to decimal point, so we have this is a decimal point. We can also have a binary point. So let's say this is here, and this is nothing but this is zero point 0.5, right? The zero point 0.5 is nothing but it's just half. So this is simply 1. We can verify that this is like 1 into 2 raised to minus 1, which is zero point 0.5, right? And it could be 0, 0, or 0. So it doesn't matter how many zeros we have here. So this is how we represent a binary number. Let's consider we want to represent 13.25. Now how we will do that? We know this is an integer part, so the binary representation is 1101. Then we have a binary point. Now this 0.25 is nothing but 1 upon 2 raised to 2, that is 1 raised to 4. So we should have some indexes here, 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 and this is 2 raised to minus 1, this is 2 raised to minus 2, and this is 2, and so on. We know that this is simply just 0.25, so it should come 0, and this should be 1, and 0, and so on and so forth. So this is how we represent 13.25 with a binary representation like this. All right. Now, what happens with fixed point representation number? Now, here I mentioned that the number of digits won't matter here. So, number of binary points or the binary numbers won't matter. But when we have a fixed point numbers, we would like to have the fixed number of bits of ones and zeros. So, let's say we have a binary, we have a fixed. So, in this case, fixed point format, we have total number of bits. So, either it could be, let's say, 8 bits the total number of bits, and then out of this total bits we divide them into two parts. One is integer and the other, so we divide these 8 bits into let's say m number of bits for integer and number of bits for fractional, correct? So let's assume that this is an unsigned number. So let's say assume that if we represent this four numbers for the integers and four numbers for the fractional point. So this is like fixed number of bits. So we will have four numbers for integer and four numbers for the fractional. So this is an integer portion and this is a fractional portion, right? Now because we keep the number of bits fixed, there's a limitation on the maximum value that we can represent with this and the minimum value that we can represent with this. Now, there's one more thing that we have to be careful about is whether this is signed or unsigned numbers. So, in some cases, let's say we have signed fixed point format. So what we do is we we instead of just two parts, we have three parts. So usually the one bit is represented for the sign, then we have this integer, and the remaining is fractional. So one bit is this, so it could be m number of bits for integer, n number of bits for fractional. And the way we represent fixed point format is we write total number of bits and the total number of fractional bits. So if I say this is 16 comma 8, in this case 16 is the total number of bits, that is 1 plus m plus n, and 8 is fractional number of bits. This is fractional number of bits. Now I'll come to the point where what is the limitation of maximum versus now in this case let's assume we have uh, one bit for a sign, 4 bits for integer, and let's say we have just 3 bits. So this is 3 bits, 4 bits, and 1 bit. So this, let's say this is an 8-bit word where we have 1 bit for the sign, 4 bits for the integer, and 3 bits for the fractional numbers. So we can compute what is the maximum and minimum numbers we can represent with this. So now we'll see how we can, we'll try to get the minimum and the maximum in the MATLAB. So what we'll do is uh, we can rely on MATLAB, to suggest to play with this fixed point format, and we'll see how we can, get more information out of it. Okay, so let's switch to MATLAB. So in MATLAB, we have a command called fi. So fi is a constructor, uh, and then we have to give some arguments into it. So v is the value that we want to convert into fixed point format. S is the parameter that says whether this is a signed number or unsigned number. W is the length of the word, and F is the number of fractional bits. So we'll use this format. And just to reiterate again, is the fi, and so this is the value. It could be any value that we want to convert into fixed point format. Then this is 1 for sign and 0 for unsigned numbers. So this is sign and this is unsigned. W is the total number of bits. This is basically word length, or we can say total number of bits. And this is the number of fractional bits. All right. Let's use this command fi 1.25. This is a signed number. Let's say this is an 8-bit, and let's take the number that we had taken earlier, 13.25. And the number of fractional bit, let's say, is 3. Okay. Um, just to get a binary number, let's take. Okay. So the number that we got is 0, 1, 1, 0, 1, 0, 1, 0. I think this is the same number that we had, we got it earlier, right? So this is 1 1 0 1 1 0 0, but this was like we didn't fix the number of bits here. So this is a fixed number of bits. This is 8 number of bits. This is a sign bit. I mean 0 means positive value, 1 means negative value, and then this is a integer part which represents number 13 in this case, and this is a fractional bit. So we suggested f is 3, right? So we had this f is 3, and this is a fractional point. So this is uh, actually represents 0.25. So basically we represented number 13.25 with this fixed point format, and we can do something similar. We can verify that in the MATLAB as well. We can also verify a negative number. So let's take a simple number in this case. So let's say this is 0.25, this is sine, this is 8 and 3. So this is minus 2.5. To get a binary number, we can represent. So this is a binary number. Now this is 1 1 1 1 1 1 0. Okay, so 1 means this is actually a negative number, and these are in basically in 2's complement format to obtain. So we have to do the 2's complement operation. So basically we have to flip the signs. So this is 1 0 0 0 0 0 0, and then this is we have to add 1. So this is 0 0 0 0 0 1 0. Okay. Um, so we know this is a negative value, and this is integer portion. Basically this is integer value 0, and in binary, if we try to convert this binary into numbers, we'll get 0.25. So we know this is negative 0.25 value. So this is how we can represent any value, uh, that we wish to represent in fixed point format. Now, there is one thing that I would like to mention here. So we talked about what is the maximum and the negative value that, so we can represent, let's say, this is infinity. So this is 8-bit and 30-bit. So this is the maximum value that we can represent with this 8-bit word, where we have the 8 bits are the total number of bits, 3 bits are the fractional bits. So this is the maximum value that we can have, minimum value. So minus 16 is the negative value. All right. We can also show them in binary numbers. So this is the minimum value that we can represent with this fixed point format. Now there is one thing to note here. When we store these numbers in hardware, we store them in integers. So let's get an integer value of this. So this is 106. So for 13.25, we have fixed point representation in binary format, and the integer value of this is 106. To get back the actual fractional value, which is 13.25, what we have to do is divide that number 106 with 2 raised to power of 3. Now here 3 is the fractional number of bits. So this is 106 divided by 8. And that's how we get our actual fractional number 13.25. So this concludes our today's video of fixed point binary representation. I hope you liked the video. If you have any question, please write them in comment section. I'll do my best to answer them, and I'll see you in next video. Thank you so much.